Hi, so this is going to be a very quick and very concise walkthrough of the very important parts of the proposal for the project implementation of geographically weighted matrix decomposition algorithms in GWLearn. GWLearn is a supervised learning machine learning library built over scikit-learn specifically for geographical data. I have this index page over here. You can access and navigate through everything you want. Even if you want to skip some parts, it's very easy for you to read. So let me begin with a brief introduction about myself and my previous experience with PyStal and scientific Python. I am a machine learning and data science practitioner. Currently a second year college student, and I also participated in Google Summer of Code in my first year itself. And I am currently the maintainer for Sugar Labs website, www version 2. You can see it in the links below. For the last 4.5 months since December end, I have been an avid contributor inside of PySal, and I have mainly had pull requests inside of libpysal and GWLearn. I have currently merged approximately 10 pull requests and opened like 15 of them. And alongside that, I have in the entirety of PySal, I have additions of 7,000 of lines of code. You can see the GitHub contribution graphs. I am currently inside of GWLearn. I am the second highest contributor with additions of 6,900 lines of code. A lot of it is in collaboration with Martin. I would definitely acknowledge that. But yeah, I've been an avid contributor in here. Then so you can quickly go through my contributions in this section, and like some research, previous research work in geography later. So some introduction and motivation. So other than this, all of this theoretical part, let me explain what this is. Basically, when we consider a global model, we take and depend upon averages. For an example, if I can say that United States of America's climate is overall moderate, but when I say that, ignore the fact that Miami has a very humid temperature, that Chicago have freezing winters, and Phoenix has a lot of heat. So basically, when I use a global model, right, I ignore a lot of small neighborhood specific things that can give us a lot of information about how basically what geographical conditions a region or a region has, right? So this is related theory according to that, some PCA basics and everything. Yeah, as I said, limitations of global PCA. PCA is obviously for dimensional reduction. So basically, it helps us with the curse of dimensionality. Not every single feature is basically not every single feature gives us a lot of information, right? So basically, we can skip out on those. That is PCA, right? Idea is to keep this project very much in sync with both scikit-learn ecosystem, basically the machine learning ecosystem, and also the PySal ecosystem, the ESDA library, SPOpt, and GWLearn PySal. PySal is a huge library. So yeah, let us just here are like a lot of the formulas we have for global PCA. Then you can basically find them here, right? And there is also so basically the Harris paper, Harris and the others in 2011, they proposed GWPCA, and alongside that they put the implementation was done in R package, and here is the WPCA implementation in R language. But currently, currently we don't have any Python native way of doing that thing. So this project also like focuses on that. Here are a lot of formulas and also a comparison between global model and local models, right? Um, You can quickly go through these math. Yeah, so also that I have like built a very small prototype for explaining how everything is working. So let me just, you can see the results that I've got. Definitely seeing that local models are performing better than global models. And also Harris paper of 2014, which is robust GWPCA, which also has outlier detection, also which outperforms the normal GWPCA. So I have in my proposal, I'm proposing to like have both of them and also some other decomposition algorithms, right? So this section basically briefs over what all changes we need to do in order to perform unsupervised learning in GWLearn. Here are a lot of brief of them. I have like went through the code base line by line and figured out how to do stuff and everything. Yeah. This is the current GWLearn's code base architecture. Let me just brief you over what is happening over here, right? We obviously have the tests, that for sure. We have search, ensemble, and linear model methods, right? So now, whenever you have to ship a new algorithm inside of either of these files, those basically extend these methods, base model, these classes, right? So basically, new algorithms inside of these three are basically overrides of implementations done inside of this. So basically, they inherit in order to reduce the overall code redundancy, right? And yeah, I have done the gradient boosting regressor. It was my pull request. It follows the same architecture and same pattern. I've done things before as well, right? Here is what we need inside of base decomposition. So we need to have a base decomposition method inside of base.py, right? So the new GWPCA or decomposition .py file, like everything inside of the decomposition.py file can extend this class in order to perform unsupervised learning. And some of the weighted covariance graph building inside of libpysal has to be done, so that not just a global graph, we need some sort of a local graph building. So that's what the weighted covariance means, right? Okay. I have like the papers mentioned by Martin, sir. I went through them very carefully, and these are some of the very crucial features, I believe, which the paper explicitly mentioned. So inside of my prototype as well, you will see that there are some specific things inside of GWPCA that are not inside of others. So maybe the GWPCA is done over is around 170 lines, but the other algorithms that we will have will be around 70 lines only. So with the base decomposition being there, we can basically extend that class and reduce the overall code redundancy to even 40 to 60 lines, like around in that bracket. So we don't have to like write 170 lines for every single one of those methods, right? Yeah. So sign convention problem was definitely there, right? Because vectors have both negative and positive signs, and they can basically point towards the same place, and that's a pretty problematic thing to have. Some collinearity diagnostic methods and some evaluation to see if the points that are lying in a distance are not redundant and everything. Yeah, the base decomposition, we need a new unsupervised base class, which extends basically the base model and scikit-learn transformer mixing. It basically extends the base model and also the scikit-learn transformer mixing algorithm. Sorry, method, right? You can see all the theories over there, but I'm just quickly making you go through everything. Here is what we can do instead of inside, for example, earlier in supervised learning, we had to fit a model. We used to put y is equal to some value. But if even if now we either don't define y, or even if we put y is equal to none signature, that should route us towards the unsupervised learning path, right? So that's what is represented in this diagram over here. And here is like my prototype implementation of base decomposition. If it's accepted, it will be pretty close to this, but I'm totally flexible to changing according to everything what Martin says. We've had discussions over the last 4 months on how like the method of Paisal is having a proper discussion before actually pushing things, right? That reduces the number of commits and the overall confusion and noise that takes place, right? So what better for us is that I don't actually use this and have a proper discussion with him. I'm totally flexible to using any other method in this project. But yeah, just a rough idea of everything. This is not the final API at all. GWPCA. So yeah, so the GWPCA class and also other decomposition algorithms classes will extend the base decomposition, and basically the others are just overrides of everything, right? And also I would like to mention that in one of my draft pull requests, right? Let me just show it to you. One of my draft pull request, the wrapper functions in base. So currently I have put a tricube kernel inside of libpysal, which will be released in the next version. And I will be implementing the libpysal kernels, like an easily callable method from libpysal into GWlearn for these kernels. This will be my pull request. It's currently in draft. I'm still waiting for the next libpysal release for that. And yeah, those kernels will be used directly into this project. And you can quickly go through all the theories. And this is like uh, explanation of the entire process, how everything is working currently, will work in GWPCA, right? Yeah, you can see this pull request, PR hashtag 825. I'll just, link it over here, I guess. No, so it's inside of libpysal, okay. Hmm. This was the TriCube kernel implementation pull request that I made. It was way back in Jan 10th. So yeah, I've been contributing for a long time now. And like I'm pretty used to with the Pysal ecosystem and everything. I know the code base. I'm aware of those. Hmm. Yeah. So let us discuss about robust GWPCA. So standard GWPCA fails for outlier detection, right? Because outliers basically mask themselves. They distort the local covariance matrix before the principal component analysis is fitted. So basically, then Harris in 2014, he published a paper and implemented a more robust way of implementing GWPCA, which also had outlier detection so that the GWPCA results are more accurate and more informative. You can go through what they actually do in the theory parts, and you can even see it is on the paper that was suggested by Sir Martin, right? It has coordinates and orthogonal distances. The earlier point that we discussed was related to that. Then geographically weighted factor analysis. This is also a decomposition algorithm, right? So let us talk about extensibility to other new decomposition classes, right? Now that I am proposing to make a base decomposition. So without the base decomposition, you will have to write every single class every single time, right? So you have to from scratch implement GWPC and all other algorithms, right, in the decomposition.py folder. But but if we have the base decomposition and basically extend the other classes, we can implement everything within 100 lines of code. And by basically just so basically the all of the other decomposition algorithms, they inherit the base decompositions, right? This is everything that base decomposition class will provide, so as to make the implementation of the other decomposition algorithms very quick and very easy, right? And obviously the other, like, since we have different decomposition algorithms, the methods will those algorithms will basically those methods will basically override the fit local class and build, like, have the differences in that way. So basically they will override and have their own differences and do what they are supposed to do, right? But all of that in less than 80 lines of code. So that is a very optimized method and a very extensible and maintainable method of writing code, right? Since the fit method, that method is always common to all, so we just have to implement the fit local method, right? Let's discuss about the extension of bandwidth search. It's happening like this, and yeah, we are implementing the score that we earlier had. Now we are inserting a method so that it can have y is equal to none and route towards unsupervised pathing, right? And yeah, this is the discussion about YCB score and not AICC-BCC. It's basically an abstract from Harris 2011 paper, right? I am completely flexible. If Martin suggests me to completely like use AICC and AIC methods, I'm all right with that as well. I'm completely flexible to any changes. I trust his intuition, and I believe he will guide me correctly onto things. Let's talk about PySal compatibility, right? We are firstly using the graph weighted covariance, right, as the input. Or maybe I can also add the kdtree.scipy method for, but yeah, that's another discussion that we need to have. But yeah, a rough idea, a very good idea of getting it is like having libpysal to build, right? So to maintain complete compatibility with the PySal ecosystem, right? The outputs are compatible with ESDR, it's compatible with geodata frames and everything, even compatible with GWR, right? SQL compatibility is definitely there. We are like using their methods only, so it's pretty obvious. So about NumPy compatibility, the input points that we are using are NumPy arrays only. They're either geodata frames or maybe pandas objects as well, right? Yeah, and we discussed about Panda API compatibility. We can use pandas. And yeah, bandwidth search basically wraps any class. This is the same diagram, right? This is like the whole of what we are trying to do and build, right? The complete inputs and complete outputs. This tells what all outputs we have and the types. And this is the inputs we have and what type are there. NumPy arrays, right? PD data frame and geodata frames as well. And outputs we have in terms of PD series and NP arrays, NumPy ND arrays, and everything, right? So as we can see, we have only one method to implement for all of these classes, which is fit local method, right? It has this different outputs and different return types, and on the basis of that, they differentiate within each other, and we can implement all of these within 80 lines of code, like even smaller than 80 lines of code, right? Including the docstring strings as well, right? Yeah, you can go through this entire diagram. So the project timeline has always is also been given, but also I'm very flexible to change this timeline. I'm completely all right with what my mentor suggests me. And if more time is to be given on something like maybe GWPC is to be given more time and more tests are to be written, I am definitely willing to change and manipulate and whatever like, is to be done with this timeline. This video, the point of this entire video was to give a rough idea of what the proposal is about. And yeah, it's basically an overview. What are the final expected outcomes? A scikit-learn compatible base decomposition framework, and extensible a method which is extensible to other decomposition algorithms as well. Right, the complete 350-hour project that we're trying to build in GWLearn completely from. All right, so this is the last section, communication and AI usage policy. For the last 4.5 months, I have been contributing regularly to PySal and seeing its systems and everything. And one thing is for sure that up till now, I haven't done a single communication using AI. It's never like I copy paste something from ChatGPT or like something. I communicate and put my thoughts and feelings and what intuitions do I have in very humanly way, and never ever like take something from AI and make the maintainers feel that we are talking to a chatbot. I have currently never done that, and I think even as a maintainer of an other open source or which comes in GSoC, I've had people who have done that, but so I know I can, on an empathetic level, relate to how it feels, and I can never wish it upon my mentors, and I promise to never do that, even up in the upcoming months if selected, right? Also, I would like to work upon building this what the spatio-temporal graph in libparser. After this, yeah, I will be dedicated. And also, during the contributor periods, I kind of have no exams at all. So I have no other engagements busy. So my entire focus will be on implementing GWPC methods and everything. So thank you so much if you've watched till here. I really appreciate.